Welcome to this video on the internals of Dart. After watching this video, you'll be able to describe Dart fundamentals, identify the core libraries of Dart. Dart is a programming language designed for building mobile, desktop, server, and web applications. It is primarily used with the Flutter framework to create applications. Let's examine the fundamentals of Dart and why these features make Dart a powerful tool for developing high-quality cross-platform applications. One of the main features is the Dart Virtual Machine, or VM. It is like the engine that runs Dart code. It provides a place for your Dart code to run and handles tasks like managing memory and executing code. It's designed to run Dart code quickly and efficiently. The Dart VM works well for both creating and using apps. Dart programs involve two important phases: compile time and runtime. At compile time, Dart code is checked and optimized, ensuring early error detection and better performance. During runtime, the Dart VM executes the compiled code, managing dynamic operations such as memory allocation and user interactions. This dual-phase approach enables efficient development and high-performance execution of Dart applications. Dart uses two ways to turn your code into something the computer can understand: just-in-time, or JIT compilation, and ahead-of-time, or AOT compilation. JIT happens when the program is running. It translates the Dart code into machine code, which is the code the computer understands right before it needs to run it. JIT is great for development because you can see your changes instantly without restarting the app. This process is called hot reload. AOT happens before running the program. It translates all the Dart code into machine code ahead of time, allowing an app to start faster and run more smoothly. Another fundamental of Dart is garbage collection, which is used to manage memory. Garbage collection automatically cleans up parts of memory that your app no longer needs, so you don't have to do it yourself. Dart uses a generational garbage collection strategy. This strategy divides objects into different generations based on their age. The young generation objects are temporary or only needed for a short time and then thrown away. So garbage collection cleans them up frequently to remove items you no longer need. The old generation are objects your app uses more often and for longer periods. The old generation is cleaned less often because these items are more likely to be used again. Let's explore an example of a chat application and how it uses garbage collection to manage memory. In the chat application, messages that have been read might be considered young generation objects because once a user has read the messages, they are not needed anymore. These messages can be removed to free up memory. However, the user's contacts in a contact list might be considered old generation objects because it is used frequently and remains in memory for longer. Dart also excels in concurrency, which is about doing multiple things at the same time. Dart handles this with isolates and async programming. Isolates are like separate workers that run at the same time without sharing memory. This prevents problems when two things try to use the same memory at once. They communicate by sending messages to each other. Async programming works by using async and await. These keywords help you write code that does not stop running while waiting for something else to finish, such as loading data from the internet. One example of concurrency in Dart includes loading data from the internet. Imagine your app needs to fetch data from a web server. Instead of making the user wait while the data is loading, you can start loading the data in the background. Once the data is ready, you can update the app to display the new information. This way, the app remains responsive and the user can continue interacting with it while waiting for the data. Also, Dart uses concurrency when reading files. If your app needs to read a large file from the device storage, it can read the file in the background. This prevents the app from freezing while the file is being read, allowing the user to continue using the app smoothly. Another fundamental part of Dart is its core libraries. Dart's comprehensive libraries offer many useful functions and classes. Let's examine some of the key libraries. The library Dart core is automatically included in every Dart program. It also provides basic functions and classes such as numbers, strings, and lists. The library Dart Async helps with the asynchronous programming, such as waiting for data to load. It includes classes such as future and stream that let you handle tasks that take time to complete. Another library is Dart I/O, which handles input and output, such as reading and writing files or connecting to the internet. The library Dart Convert helps with converting data such as turning JSON, which is a format for storing and sending data, into Dart objects and vice versa. Finally, the Dart Math library provides mathematical functions and constants that are useful for complex calculations. These fundamentals collectively make Dart excellent for creating cross-platform applications. Its combinations of the Dart VM, JIT, and AOT compilation, garbage collection, concurrency, and core libraries will help you write better applications so you can build high-quality apps for mobile, web, or servers. In this video, you learned that the Dart VM runs code quickly and efficiently in two phases, compile time and runtime, enabling efficient development and execution. Dart uses just-in-time or JIT compilation, which translates code while the machine is running, and ahead-of-time or AOT compilation, which translates code before the program is running. Garbage collection helps manage memory and automatically cleans up unneeded young generation or temporary and old generation objects. Dart achieves concurrency with isolates, which run at the same time without sharing memory, and async programming, which uses async and await to keep the code running. Dart has core libraries such as Dart Core, Dart Async, Dart IO, Dart Convert, and Dart Math, which offer many useful functions and classes.